So now that we've talked about the two-parameter version of create, we're going to see how it can be used by looking at case study ex4. And this is a multi-part case study. Part one of the case study shows how to implement a generic blocking subscriber, which is kind of fun. It's a nice reusable class that you can leverage for other projects. And we need to make this class because there's something missing, at least from my point of view, in the Project Reactor Flux class. There is no blocking subscribe operator. There is a blocking subscribe operator on the observable class in RxJava, but there is no blocking subscribe for Project Reactor. So we're going to implement a blocking subscriber, which is going to use a countdown latch in order to be able to allow blocking from the client's point of view. Now, the reason that there is no blocking subscribe in Project Reactor is because people made the policy decision that that was an egregious abuse of asynchronous programming. However, for certain things, it comes in very handy, so that's why we have one here. So we're going to take a look here at the ex4 project in my Reactive Flux folder in my Live Lessons GitHub repository. So here we are in the ex4 project. You can see this is the test program entry point. We're going to register 3 methods under test fraction multiplications blocking subscriber 1, test fraction multiplications blocking subscriber 2, and test fractions multiplications overflow strategy. However, we're not going to talk about any of those methods yet. Instead, we're going to go ahead and take a look at the back pressure subscriber class implementation. So here is back pressure subscriber. So this allows us to make a back pressure aware subscriber implementation that will handle blocking, which is otherwise not well supported by Project Reactor. Now, you don't have to use it in a blocking manner, but it's basically its purpose. And nor do you have to use it in a back pressure aware manner, but it's capable of being used in a back pressure aware manner, as we will see later. So we define several fields here. We have a consumer that's going to be used to handle each of the values produced by onNext from upstream. We have an onError field, or we have a field called merror consumer that will handle the onError signal. We have an complete runnable field that will handle the onComplete signal. And then we have a request size, which is used if you want to invoke back pressure. We have a string buffer that we use to write debugging messages into. We have a subscription field that will hold the subscription given to us from the publisher when we subscribe. We have a couple of atomic integers that are used to keep track of the number of events we've received, and we need this if we're going to be able to handle back pressure in a correct way. And then down here we have a countdown latch. A countdown latch is a Java barrier synchronizer that came in the Java 5 release, and we use it to allow the caller, the thing that's creating this blocking subscriber, to wait for all the processing to complete asynchronously before it continues on its merry way. Here is the back pressure subscriber constructor. As you can see, you pass it a bunch of consumers and runnables, which are things that are going to be handling the events. We have a long, which is going to be used to indicate whether or not we're going to be doing back pressure for this particular subscriber. And then we have a string buffer that we use to log information in. That's mostly there just so when we run the program, we can see what it does. In a production code, you might or might not actually have that parameter. As you can see, we just assign all those fields with the parameters, and then we assign the mLatch field with a new countdown latch with an initial count of 1. And what that means is if someone goes to wait on that countdown latch, if the value of the countdown latch is not 0, then the caller that's waiting on it will block. And it's only after all the asynchronous processing is done that that countdown latch is counted down to 0, thereby allowing the caller to continue. And then we print out some useful diagnostic output so we know what's happening. Here's the onSubscribe hook method. This is what gets called back automatically from the publisher when we subscribe. So when the subscriber subscribes, this method is automatically called back by the publisher, and it gives it a subscription object. We stash that away in a field, and then we tell that subscription object, here is my request size. If the request size is max value for an integer, for example, that means no back pressure. If it's a value less than max value, it's interpreted to mean make that the number of events that are received before we have to wait for the next request to come back from the subscriber. Here's the onNext hook method. You can see it calls to the consumer fields accept method to do whatever that consumer is going to do. We increment the total event count by 1, and if the number of events that are processed thus far equals the request size, this means that we have enabled back pressure. In that case, we will request the next tranche or chunk of events from the publisher, and we reset the value to 0. That just is a way to reset it when we've processed and requested the next chunk. The onError hook method does some logging, indicating what we've received. It calls the error consumers hook method, so it'll do something with that error. And, very important, we release the countdown latch. So if something goes wrong, we're going to unblock anybody who's waiting for the blocking subscriber to be finished. Here's the onComplete hook method. Once again, we log the information. We call the run hook method on the mComplete runnable field, and also we release the latch so that we'll let the caller unblock. Total events is just a helper method that returns a number of events. And then the await method, this is an important method. This is what can be used by a client, a caller of this service, this blocking subscriber, to wait for all the processing to be done. So when this is called, we log it, and then we say to the countdown latch, please await for someone to call countdown, which, as you can see, occurs when we either get an onComplete or onError event, and this will block the caller. And then we return an empty mono to indicate that all the processing is done, and that's useful when we're dealing with things that involve the use of the async task barrier. So that is essentially the back pressure subscriber. We're going to see how it's used here shortly. We're actually not going to use it for back pressure, but we're going to use it for blocking, and it'll be interesting to see how that gets used when we look at other parts of the case study.